In this video, we're going to see how to calculate the area of a sector and a length of an arc. To quickly recap what these terms mean, remember that when we take a slice of a circle like this, we get a minor sector contained within a minor arc and the two radii, and a major sector contained within a major arc and the two radii. And when you get questions about this stuff in the exam, they're normally going to give you this angle here of the minor sector and the length of the radius. Now, if you want, you can just memorize these two formulas here, and by plugging in the angle as x and the radius as r, this will give you the area of a sector or the length of the arc. What I want to do in this video, though, is go through the concept behind the formulas so that they make sense, because when we break them down, they're much easier to understand, and they're also a lot easier to use in tricky questions. So for me personally, the best way to think about this topic is to think about how big the sector or arc is as a fraction of the entire circle. For example, if our angle here was 90 degrees, then that would mean that our sector was 1/4 of the full circle, because remember, a whole circle is 360 degrees and 90 is 1/4 of 360. And so this means that the area of this sector would be 1/4 of the area of a full circle, and the length of the arc would be 1/4 times the circumference of the full circle. So to find out the area of our sector, we just do 1/4 times pi r squared, because pi r squared is the formula for the area of a circle, and then for the length of the arc we'd do 1/4 times 2 pi r, because 2 pi r is the formula for the circumference. So if the radius of our circle in this case were 6 centimeters, for example, then the area would be 1/4 times pi times 6 squared, which is 28.3 square centimeters, and the length of the arc would be 1/4 times 2 times pi times 6, which is 9.42 centimeters. Now, this technique works just fine if you've got something easy like a quarter, a third, or 1/2 of a circle. The issue, though, is that if you have a more complicated angle like, say, 113 degrees, then it's a bit harder to know what fraction of a circle you have. In these cases, you need to write your fractions with a denominator of 360, because there are 360 degrees in a circle in total, and then you just place whatever angle your sector is as the numerator. So in this case, because the angle of the sector is 113 degrees, our fraction would be 113 over 360, or in other words, our sector is 113 360ths of the circle. So if the radius this time was 15 millimeters, then to find its area, we'd see 113 over 360 times pi times 15 squared, which would be 222 square millimeters, and to find the length of the arc, we'd do 113 over 360 times 2 times pi times 15, which is 29.6 millimeters. Before we finish, let's have a go at this question here using the two equations from the start of the video, and remember that the x just means this angle inside the sector. Also, don't worry that here we're only given the sector, not the entire circle. Sometimes they'll just give you this sort of shape, and they will tell you that it's part of a circle, or they'll give you the radius, and if they give you the radius, you know it must have come from a circle. So for part, it's asking us to find the area of the sector OAB, and OAB is just a way of describing the sector on the left, because OA and B are points around the shape. So we're going to use our equation area of sector equals x over 360 times pi r squared, which if we sub in the 70 degrees and the 14 will be 70 over 360 times pi times 14 squared, which will give us 120 square centimeters. Then for the length of the arc AB, so just the arc in between A and B, we do x over 360 times 2 pi r, which will be 70 over 360 times 2 times pi times 14, so 17.1 centimeters. Anyway, that's everything for this video, so I hope that was helpful for you.